Today we're going to talk about hybrid retrieval augmented generation, or RAG, and why you should consider hybrid retrieval when your solution requires factual-based answers and have very small tolerance for errors. Anyone who's built a RAG pipeline is very familiar with vector-based RAG, or using vector embeddings to retrieve similar context based on user's prompt. Here's a graphic for your typical vector embedding pipeline. Users provide a prompt, embeddings are generated based on that prompt, and we use a vector database in order to perform semantic similarity search to retrieve data to answer the question. It's worth talking about what semantic similarity is when it comes to data retrieval. When using vector embeddings, text is converted into numeric representation so our AI pipelines can more efficiently deal with text. Then we use semantic similarity to capture relationships between words, concepts, sentences, and even entire paragraphs. This is possible through the use of GPUs and AI algorithms like KNN search. There are a multitude of different calculations to quantify what similar means, whether that's through cosine similarity, Euclidean distance, and so on. But how does semantic similarity relate to providing answers to users' questions? This is where a lot of AI solutions tend to fall apart. We treat semantic similarity and the data that's provided through using semantic search as possible answers to a user's question. However, it should be noted that semantic similarity, or the probability of how close a chunk of text is to another piece of text, doesn't necessarily contain the data required to answer a question. There are a number of things to consider, like how the question is being phrased, how the data is being represented in the vector database itself, what embedding model is used to chunk that text, and that's only to name a few. You can see in this example here how it's possible based on probability of semantic similarity, we might arrive at an incorrect answer. If you think about it at a fundamental level, probability or chance isn't great at providing a certain or known answer. This is where we start to see other methods for retrieving data in our AI pipelines. One such option, among many, is using graph-based retrieval, also known as graph-based RAG. What sets graph-based RAG apart from other retrieval mechanisms is the ability to use knowledge graphs. Knowledge graphs are powerful because they're based on relationships between your data and the data points. Effectively, you're retrieving all facts related to a particular user's question. The benefits are creating the highest level of relevance for the data being retrieved, and the accuracy of the facts, which provides better answers to the user. The drawbacks include having to start with structured data and also having to manage the graph relationships. This is similar to how you would manage SQL tables, primary keys and foreign keys. This is what a typical graph-based RAG solution looks like. Note that it's very similar to how vector embeddings work. The only difference is that you're querying a graph database in order to retrieve these knowledge graphs containing highly relevant and correlated data based on the user's question. What's really interesting is that you can actually combine multiple RAG architectures. This is a representation of combining a vector embedding-based RAG solution with a graph-based one. You can see the vector embeddings and knowledge graph retrieval process are unchanged. The only difference in this architecture is how you present the vector embeddings and knowledge graphs to the large language model in order to arrive at an answer. For this demo, we're going to show how relying on vector embeddings alone in order to answer questions can leave you with answers based in facts, but answers that are factually wrong. Then we're going to take a look at how we can remedy this using hybrid RAG. We're going to do this by using an example of two news stories. Both OpenAI and Google had made bids at different points in time to purchase Windsurf. And that's the context we're going to use to start our demo. So let's go ahead and take a look at that demo using vector and hybrid-based retrieval. So we're going to take a look at tech history through the lens of the British Broadcasting Corporation news dataset. Within this dataset, we have two news articles relating to the purchase of Windsurf. We know that OpenAI had an initial bid several months earlier, but that deal ended up falling through in favor of Google's acqui-hire for the Windsurf team. We're going to use these news events to explore how semantic similarity search, although great for finding similar text, can potentially lead to inaccurate answers. We've already ingested our dataset and we're going to ask two questions. How much did OpenAI purchase Windsurf for, and how much did Google purchase Windsurf for? So let's go ahead and run our two prompts. Here you can see we have two different questions and we're also getting two different answers, even though these two events and data points have extremely high correlation to each other. For the question, how much did OpenAI purchase Windsurf for, we have one answer that says OpenAI purchased Windsurf for $3 billion. And for our second question here, how much did Google purchase Windsurf for, we have the answer Google purchased Windsurf for about $2.4 billion in licensing fees for an acqui-hire for Windsurf's technology and under non-exclusive terms. So this is one of the challenges that vector embeddings has when it's attempting to provide concrete answers to users' questions. Next, we're going to take a look at asking those same questions but using a hybrid RAG pipeline. What makes hybrid RAG uniquely qualified to provide answers to users' questions is that we're going to use knowledge graphs in order to ground answers to facts. Then we're going to use semantic similarity search to use vector embeddings to provide nuance to those answers. So let's go ahead and run the same questions through our hybrid RAG pipeline. As you can see here, we have the question, how much did OpenAI purchase Windsurf for? And here you can start to see the answer. OpenAI agreed to purchase Windsurf for about $3 billion, but according to Bloomberg News, citing people familiar with the matter, the proposed acquisition never happened. And you can actually see the conflicting info and the conflicting factual information between OpenAI and what ended up happening, with Google performing the acqui-hire for talent and technology rights. And the same is true for the question, how much did Google purchase Windsurf for? We have the answer. Google paid $2.4 billion in licensing fees as a part of their acqui-hire, but we also are able to see the conflicting info with the initial OpenAI article. So as you can see, we have two very different results when compared to the semantic only based answer. We're able to detect in the OpenAI question the inherent conflict with the events that actually had transpired. And for Google, we're able to provide factually consistent and representation based on the events that happened. I hope you enjoyed that demo. So like everything in life, options come with pros and cons. Using knowledge graphs is great at factual based answers. It's ideal especially for known or concrete answers. Think of this as a math problem where there's only one correct answer. But graph-based retrieval is not great with textual nuance. Now, vector embeddings are problematic with definitive answers, but they're great with ambiguous answers. One great example of this, if you hit a problem in a Kubernetes deployment for a pod, there might be a number of remedies you might consider in order to fix the pod deployment. This is where vector embeddings really shine. But again, the takeaway here is similar sounding text doesn't necessarily have to contain the answers to your question. If you're looking for resources, I'd invite you to take a look at the hybrid RAG project using vector embeddings and graph contained within GitHub. I've also written a number of blog posts on the subject of hybrid, graph, BM25, and vector retrieval pipelines. Like always, Instacluster is great for your managed data service needs, where you're able to easily deploy data solutions like OpenSearch, Kafka, Cassandra, and Postgres. Thank you for listening, and I hope you enjoyed the presentation.